Hey, today I want to talk to you about expression-based programming, which is super powerful, probably available in the programming language you use. And yeah, it's something that I think you'll see as a powerful way to make your code more concise. The first class that I took in university was a C programming class, right? And a lot of the languages I've used in my career have been C based. You know, they have braces, they have semicolons, you do like return, C++, semicolon. They're statement oriented. But now, right, I found myself really enjoying programming with expressions, expression-based programming. And even though the languages I'm using still are C-based with braces and returns, they've embraced a lot of expression-oriented features. Things like implicit returns, if expressions, match expressions, single expression functions, just generally using expressions a lot. If that doesn't mean anything to you, well, I'm going to try to explain what it is. Because these things can seem a little confusing at first if you're not familiar with them, but they can make your code a lot more readable, make your code have more clarity and more conciseness once you get used to it. And you know, if they're not in your language today, they might be in it at some point. So I'm going to cover a bunch of languages today and how they work with expressions. But really, I just want to show you some code and kind of explain to you this simple concept about working with expressions using a whole bunch of examples. But yeah, let me just show you some code. So going from statements to values is sort of what expression-based programming is all about. So here's some Rust, and these are expressions, right? X plus 10 or add X to Y, those are expressions because when they're evaluated, they return a value, right? Where here we have some statements. We're still working in Rust, but you know, let y equals x plus 10, that doesn't return a value, right? That's performing an operation for a side effect of setting that y value. Same with like let z equals add x plus y or print line or whatever. Those are statements, right? Where these are expressions. Now let's talk about returns, right? If you are working in a programming language like this is Java right here, still a C style language with the braces and return statements. My sum function here returns an int. So on this last line, I do return p1 plus p2. Simple, right? In C languages, you can return the value of an expression with the return keyword. And there's lots of times you can do that. You can do an early return like in an if block, but generally you're returning the last executed statement for that whatever branch you're in. And the thing that you're returning is an expression, is something that evaluates to a value of the type of the return type, right? This may sound obvious, but I'm going somewhere because if you try to return a statement like assigning something to a variable, or here I'm trying to return print line in Java, I get unexpected return value is the error, right? Which is just to say you can return expressions, but you can't return statements. Like returning a statement just doesn't make sense. That's a little bit contrived, but I'm going somewhere because note that if a function has a return type, this is void, so it's not a good example, but here, add numbers, this function has a return type, right? And the return keyword itself is often redundant because we know in the last statement of that branch, we need to return something of that type. So saying return is almost duplicative or something, like it's unnecessary because of course we have to return at that point. Here's some Ruby. I said I'm gonna bounce around languages. So we got Ruby, Java, Kotlin. I don't know if there's Swift in here. Lots of Scala. But yeah, this Ruby adds numbers and returns an integer, right? So on that last line, you need to return a value. So here you're returning a plus b. But also, right, because we know we need to return there, you could actually just remove the return statement like this. And it would be the exact same result, right? Ruby is not exactly a C language. Instead of braces, right, it uses like this end keyword, right? And it doesn't have semicolons like many, like C does. But this type of omitting the returns, implicit returns, or expression-based programming, is possible in many languages. And you can see how if you have a bunch of branching, this might work, right? So we're still in Ruby, right? And we're just returning a string, which is kind of the sign of the integer, right? It's either positive or negative, or it's 0. And we have 3 branches that do that, right? And so we don't need to say return on any of these branches because each branch is exclusive. Hope that makes sense, right? If you aren't used to this style, right, I think a lot of people find this confusing because they're used to just scanning and looking for returns. But I want to show you why like this actually is quite readable once you get used to it and can actually improve the way you code. Trust me, it takes some getting used to, but I think it really can improve the way you code. Here's, for instance, right, the exact same code in C, right? And here we have the explicit return statements. If number is greater than 0, then it's positive, right? And we return. So we break out of the function here. Otherwise, we fall through to this next return where it can be negative, and then, we continue executing down and hit this final return statements. It's the exact same logic, right? But expressed in a different way. But if you were to take that code, right, and move it to Rust, which is, has the same sort of C using braces and whatever, but has this expression-based implicit return structure, right? So now what we're doing is we don't need to say return here. We don't need to say return here or here because each branch is exclusive. Each one of these is the last statement in the function, and so the return is implied. And something that's nice once you get used to that, right, is these examples are both easy, anyone can understand them, but with early returns, you have to kind of follow the chain through because there's kind of a fall through case, right? Whereas if you structure it with these else's, each branch only, what's the terminology I want? Each branch is exclusive, right? You're only going to hit one of these possible branches. That makes it a little bit easier to trace, I find, once you get used to the style, of course, right? So you could do this in a whole bunch of languages, right? This is Kotlin. It's actually less common to do this in Kotlin, but you can do the same thing, right? So we're doing the exact same implicit return structure. Once you have this idea that, expressions return something, and so you don't need the return because the return is implicit, you can do something cool, which is if expressions. Let me show you. So here's the same code. It's Scala, right? And then I'm kind of wrapping it. I have this thing called exclaim number, which just adds on an exclamation mark. It doesn't probably make sense as code, but it works for my example. The problem is, if we decide, well, we don't actually need check number, let's just inline it in there. All we need is exclaim number. Once you have that idea of expressions or something that return a value and you don't need to return, you can take it further in languages that support it with if expressions, right? So here's the same code in Scala. We have the same check number function, but then we're using it here in this exclaim number that just adds an exclamation onto the end. That's fine. It's kind of a silly example, but think what happens now if we need to inline this check number because we don't actually need it as a standalone function. We'll just replace it here. Well, that's not going to work, right? Because this, each of these branches isn't going to be able to assign to an S. So you'd have to end up with something like this in theory, right? I have to declare a variable and then kind of mutate it, setting its value in each of these branches and then returning it at the end. I think this is just a lot less nice, right? You got to mutate a string and track it. Like it's just a pain. However, what happens if you do this, right? So now, because I know that if is an expression and each branch returns as a value, I can set a value equal to that, right? This is an if expression. It's so simple that it's almost hard to talk about, right? You can just assign the value of an if, expression to a value. There's not even really special syntax, right? You already know how to do assignment. You already know how to do if statements, and you just bring them together. I love this kind of stuff, right? The if else control flow that I already know. It can work as an expression with the assignment that I already know without even needing new syntax, right? Just kind of following the way I know these things work. This, of course, these if expressions also work in the languages we've been covering so far, right? So here's here's Rust. So in Rust, we do the same thing, right? We just use a let, but we can assign the output of this let into this if, and that means we don't have to, initialize a value and then mutate it in each branch. We can just set the result equal to this S because we know that this if is an expression, right? This if as a whole evaluates to a value. So nice. Here it is in Ruby, same idea in Ruby. Then you might be thinking, okay, well, if I can assign the result of an if to a value, like what about other control flow, right? Can I use various other control flow and do the same thing? Well, if they're expressions, you totally can, right? So here we are back in Rust and we're using a match. It's just a different way to reformulate these conditions. But this match is an expression, and so we can assign it to a variable, right? And that's just so nice. Once we've done that, right, we can take things further. We can just keep going with this concept, pushing through with expressions a bit. And some of really pushing expressions may seem like too clever or concise to you. Let me see. I think my tastes may differ from some people, but I think it's an interesting exercise to think about how far can we push this idea of expressions, right? So as I said before, these are expressions, right? Now we're in Scala instead of Rust. 4 plus 3, get error. Those are all expressions, right? They evaluate to a value. But an interesting thing to think about is that a block, right? In a C language, it's denoted with these brackets. It can also be an expression. So this block is an expression because it returns a value at the end, right? This is all equal to 7 when you evaluate this. And therefore, you can use that block just like any other expression, right? So here, in an if statement, right, you have a certain, here's my if expression that returns a value, and we have various branches. This one branch just has a single expression. The other branch has a block, right? And this block returns 7. Nothing crazy there, right? But you can also just assign a block expression to a value, right? Here, I'm just have this value result that's equal to the values of this block. And because it's a val in Scala, this means it's a constant, right? It's not changing. And this could be great if I have some sort of complicated calculations to arrive at this constant value. I could just put it in a block and still keep it as a constant, even though there's steps to calculate it, right? I can assign a value to a block. So we can do the same in other languages, right? Here's Rust. So here we're doing a block expression in Rust. Same exact thing, except we need some semicolons and we use some lets. Once you kind of think about this idea, right, that a block can also be an expression, then a function declaration, to me, it starts to feel like you're just assigning an expression to a type signature, right? To a function signature. And then you might be thinking like, okay, if I can assign a block expression to a function signature, then why can't I assign any expression at all to a function signature, right? So I mean, just to break down my example, right? Here we are in Scala, I believe, although we're missing a return type. So there's kind of a bug in my code here. But this here is my function signature. And then the body of it is this block, right? And this block evaluates to a value, right? So all we're really doing when we declare a function is giving it the function signature and then giving it the block expression that it will evaluate to get the value depending on, the declared parameters typed in, which are brought into scope. So if you can do that with a block, why not anything else, right? And of course you can in many of these languages. So here's Ruby, right? So instead of having the end that you would need in Ruby for this double, right? This double here, you could just do it on a single line because this is an expression, right? This right-hand side is an expression and we just need to assign it to this value. This right-hand side here is an expression, and so we assign it to this function definition. Same for this Fahrenheit to Celsius, which should all be on one line, but, word wrapping. All of these are expressions and we're just assigning them to a value. So it's nice, like you can just drop these braces. If you're just doing a single expression, you can just assign it directly, right? You don't need the block syntax. You could do the same thing in Scala, in Kotlin. So this is Scala versions of the same stuff. And if you change this def to foo, then it's Kotlin. Same idea. Single expression functions is what we call that. I find this approach pretty, beautiful and concise. You can just write these very small little methods that do a lot of heavy lifting, right? Not everything is going to be a single line declaration, but when you have them, it's quite nice to be able to do it so concisely, right? Not everybody agrees with that though. Some people don't like this single line version and they have some good points. So let's talk about that next. This is just an if statement, right? Probably you've seen these before, hopefully. And we have a condition and then we have a statement, right? So if this condition, then we do something. So this is not an expression because we're doing something for a side effect. But as you know, there's more than one form of if, right? There's also this form where we have a condition and then we have a couple of statements that do things, right? So there's two forms. The single expression function that we saw earlier is kind of a mirror of that single if form where it's just all in one line. And that single if form is not liked by all, right? I've worked in code bases before for certain where you weren't supposed to do this. There was like a linting rule against having this single form. And you can actually put this on two lines, right? With the do something on the line below. And the complaint is that people say, well, if somebody goes to add something, goes to add this do something else, and they miss that there's no braces there, then they're going to end up missing the condition. That basically that it can be confusing to have this single form as the code base evolves over time. Just throw in the block just in case is kind of the attitude. That's fine, right? In fact, some languages take that a long ways. So in Rust, for instance, you cannot have that single line form of if. Here is a single line if statement, if expression, right, in Rust, because we're assigning it to a value. But even though it's on one line and it's a single expression, Rust says, no, you must always include these blocks, right? Just for consistency's sake, always put the blocks in. And I think that's a fine attitude, right? There's a certain consistency to say that ifs always look like this, right? They always have this shape. Although I do think there's a consistency of the other side when they're saying expressions can be a block with multiple things, or they can be single things, and you can assign, any of them, to an if condition or to a method definition. But yeah, Rust says always with the blocks, always need to have the braces, right? So then in Rust, to do these single expression functions, well, you can't exactly do them on a single line. You need to put in the braces. They're mirroring that same structure that they have in the ifs, where they're saying the braces are always required, right? So it ends up the same code, except you just format it differently and you need to put them in the braces. So it's very similar, but not quite as concise one-liners. I think this is fine, right? Like Rust has a certain perspective on to do things, and as we push expressions further and further and try to write more concise expression-based code, you don't have to go all the way. And Rust kind of says, on our bus to expression town, it pulls the rope and says, I'm off here, expressions are great, but let's always have a single way to define functions. There's a certain clarity to that, a certain practicality. But other languages keep going further. So I want to keep going further. Let's see where this goes, right? If we're in Scala, we can write a max function like this, right? Very simple. If x is greater than y, return x, otherwise return y. This is like some code you might expect in C or whichever language, right? Very traditional statement-oriented approach. But because we know that this if can be an if expression and we can drop the returns, and this is just a single if, we can change this code, right? We can do a single expression function just like this, all in one line. And in fact, it doesn't even need to be all in one line. It just needs to be all one single expression. And isn't that nice, comparing this to this? I mean, they're both very trivially small, but I just love the conciseness of this approach right here. You could do this in Kotlin as well, right? So here's the Kotlin, maybe more C style, early return style of, the temperature. I guess we switched from temperature to doing integers, integer signing. But we can easily change that in Kotlin to this, right? To doing a if, else, else. And we don't need those wrapping blocks, right? This is very concise, and I think it reads very well once you get used to this approach, right? Maybe at first it's confusing because you're like, where's the braces? But this is nice. I like it. And then as we discussed earlier, right, it's not just about ifs that you can do this style of control flow with, right? You can use something like a case statement, which in Kotlin is this when, and now, I really have this nice structure where I'm just outlining what my rules are and what the return things are. It's very concise. I like this. We can, of course, do the same thing in Scala using a match statement. You can see it's a little bit longer because we need to have this case statement here and an if, but both of these are quite nice, right? I think the Kotlin one is a little bit even more concise. It's almost just a direct encapsulation in the concise way of the business rules of when we return each string. I think it's cool. Rust, as I mentioned, right, it doesn't support dropping those braces, but it does support, just this returning this expression control flow from a function, right? I think this code is great. We have traffic light red is stop, traffic light yellow is caution, traffic light green is go. There's very little extra here, right? Besides outlining the rules that are being evaluated, there's very little else here. And I like that. I like the clarity of this kind of expression-based approach. So like practically speaking, I think that some of these examples I've shown, like the Kotlin when, that's a single expression function, is maybe pushing things because you have actually some branching and no blocks. Maybe that's a little bit too far. Maybe Rust is sort of at the ideal, right? Where we want to define an expression but still put it in braces once we get some control flow. But either way, I think that this idea of focusing on expressions instead of statements is just a powerful thing once you get used to it, right? You can have less code and, less syntax, less like semicolons and returns and braces, and just directly explain the rules that you're evaluating. I think it's just powerful. And I would encourage you to dive into these languages and experiment with the code and how you can use expressions to get more elegance and clarity, right? It excites me to think that somebody thought carefully about little distinctions in the programming languages like statements versus expressions that evaluate to values and how we can use those to kind of more declaratively describe what we're doing, right? And it leads to increased ergonomics once you get used to it. And I think that's why all of these languages now have these features, which originally come from like functional programming, but work really well in the context of these languages because they're so clear and concise. You start with your C-type language, notice that maybe the returns aren't needed because they're kind of redundant, and you pull on that thread, maybe you change how you do branching, assign expressions directly to functions, and pretty soon you have an even more powerful way of writing software, of reading software. I just think it's really well thought out, and I think that sometimes people see these concepts and they're like, oh, where's the return? How can I read this? Or where's the braces? I don't know. I just want to say, like, get past that familiarity barrier and play around with these concepts, because I think that if you get used to them, they're really kind of like a finely crafted tool that really fits together well and lets you describe what you're doing. Expression-based programming, super, super valuable. Speaking of things that are finely crafted, that are super valuable, I wanted to tell you about Earthly. You're on the Earthly YouTube right now, I assume. I work for Earthly. We make a pretty sweet build tool, open source build tool, so that you can run your CI builds locally, so that you can get faster builds because you're caching individual steps, easier to debug if something goes wrong in your builds, and you could probably use it with your existing CI. Check it out. Like, Earthly's pretty awesome. We care a lot, as you could probably see, about making code better, making software development better. So take a look at Earthly. And yeah, especially like take a look at expressions and expression-based programming and let me know what you think. Maybe you play around with it and you still hate it. I don't know. But for me, it's the wave of the future. Thank you.